Merhaba! Welcome to C-Day, Turkey, where we're about to experience one of nature's great spectacles, a total eclipse of the sun. I'm your host, Paul Doherty, from the Exploratorium in San Francisco. And on this very special Sun-Earth Day, the Exploratorium and NASA are bringing you live coverage of the total solar eclipse. Let's take a look at our telescopes right off and see how the eclipse is developing. First contact, as the moon touched the sun, happened about 20 minutes ago, and as you can see, it's already taken a big bite out of the sun. We're going to be looking at several different telescopes. The one you saw first was a white light telescope, although it looked a little orangey. And we also have a telescope here that's showing a wonderful prominence, bright light from the sun reaching out into space. This eclipse will go total in about 1 hour, and will bring you totality as well. Eclipses are rare. The last eclipse was March 23rd, 2003, and you had to go to Antarctica to see that eclipse. This eclipse is going to go through 14 countries, passing across the Atlantic from Brazil, through Africa, across the Mediterranean, here to C-Day, Turkey, on across Turkey, the Black Sea, Russia, and on to Mongolia. So we have a great show for you today. For the next hour, I'll be talking with the mayor of C-Day, who will welcome to our theater and has welcomed us to his theater. And I'll also talk with Isabel Hawkins, Dr. Isabel Hawkins, about sunspots. She'll be my co-host. We'll look at the eclipse from space. We'll look at the sun from orbiting telescopes. We'll have some views for you of the auditorium here, the theater in C-Day. In fact, now we ought to have the hydrogen alpha filter coming up. We'll look at some odd shadows. And now, having seen the progress of the eclipse so far, I'd like to welcome my co-host, Dr. Isabel Hawkins. Hey, Isabel, welcome.
Well, thank you, Paul. Well, it's such a pleasure to be here.
It's good to be here.
Thank you for having me.
Yeah.
And it's wonderful to be here in C-Day. And I also would like to welcome all of our remote audiences at museums all over the United States and the rest of the world.
Well, we're going to start right off by asking the most important question today. What is an eclipse?
Well, an eclipse, a total eclipse of the sun, occurs when the moon passes between the sun and the earth. And the full disk of the moon exactly covers the entire visible disk of the sun. Now this allows us to view the beautiful outer atmosphere of the sun, which we call the corona. And that's a really rare spectacle, and so we're going to be able to enjoy it today.
Well, we have some demonstrations to show this.
Yes, we have some demonstrations to you because, amazingly, the moon is much smaller than the sun, and yet it can cover it completely. So we're going to show you how that happens.
Okay, let's go back here. Here's our model of the sun, a scale model, and I've drawn on this piece of plastic the size of the Earth and the moon. So it would take 100 Earths to line up side to side to make the diameter of the sun, and it would take 400 moons. And in fact, I've spaced these at the correct Earth-Moon scale distance. So it's really amazing to think, how could such a small object as the moon block out the much larger sun?
I know, and also this distance, can we demonstrate that distance with another prop? I think that will be helpful for people.
There you go. So we have another scale model of the Earth and the moon, because most textbooks, you just don't get the view of the size and scale of the lunar orbit. So here we have the correct scale. It takes about 4 moons to go across the Earth. And here we have 30 Earth diameters, 30 diameters of the Earth to go from the Earth to the moon. So this, remember this, and you'll really get the scale of the solar system.
So it's still amazing to think that such a tiny moon can actually cover the entire surface of the sun. As you mentioned, Paul, the moon is actually 400 times smaller in diameter than the sun, and yet it's able to cover the sun completely. So we have a very simple demonstration for you that will allow you to visualize that, and perhaps wherever you are right now, you could try this demonstration at home and get the sense of how this happens. And we're going to use my thumb and Paul's head to do this demonstration. Now, if my thumb represents the moon and Paul's head represents the sun, of course we can see that my thumb is obviously smaller than Paul's head. So how is it possible that my thumb representing the moon can cover Paul's head representing the sun? Well, we're going to demonstrate that. So here comes the demonstration. Take that thumb and close one eye and look toward another person distant from you and move your thumb in such a way back and forth until the thumb covers entirely the head of the other person. So here it is. The moon is covering the sun. It's an amazing thing. And remember, 400 times bigger. So how can that be? The sun is 400 times bigger. But the moon is 400 times nearer us. And that's how this happens.
So we just experienced the total eclipse of my head.
That's right. The moon is looking pretty good.
Well, you sort of think that there'd be an eclipse every month as the moon went around the Earth, but eclipses are rare. That's what I said.
Right. I wish that total solar eclipses happened once a month. I think we would be very lucky and many more people on Earth would be able to see it, but that's not so. And we'll explain why.
Got it. Oops. So if this is the Earth and the hula hoop is the moon's orbit, the moon, you'd think the moon would go around the Earth and line up with the sun every month, making a total solar eclipse. But we know that doesn't happen. What happens is the moon's orbit is tilted, so that as the moon goes around the Earth in its orbit, starting here, and the moon goes around the Earth in its orbit, it passes above the sun at this time of year. So there isn't a total solar eclipse. But the moon's orbit behaves like a gyroscope. It stays in this orientation as the Earth moves around the sun. So let's make the Earth go around the sun. So we'll go from winter to spring here in C-Day. And now, keeping the same orbit, as the moon goes around the Earth, now it lines up with the sun. And so today, there'll be an eclipse.
That's fantastic. And actually, that is what is happening right now. We have that perfect alignment. So let's look at that alignment with our telescopes and see what kind of wonderful equipment we have brought to show you the total solar eclipse.
So, I have a guest here. This is Hi, Larry Kenworthy from Magnetic Images in Marin, California.
Nice to see you again.
Look at this array of telescopes, Larry. What did you bring for us?
Well, this is our best one so far, I think, after the three events that we've done together. We have a terrific group. And with the help of Bill Dean and Eric Blackhurst from ODP and OPT, I should say, and Coronado Instruments, yes, and our video crew, Aaron Rosen especially, in helping translate these wonderful optical images into the video that we're sending home. It's pretty terrific. It's pretty terrific.
So what are they? What's this great thing here?
Well, this is a high-res still camera array, different focal lengths, and there are several different filters involved here also that Eric's working on. So we'll hopefully get to see a little bit of this in the near future when he gets it home and processed and so forth.
Great.
And then for our telescopes, we have a white light telescope over here that's a close-up telescope that we'll see off and on prior to the eclipse, and then that will probably be our primary telescope during the eclipse. Because once you get into the eclipse, the filtered telescopes, right, there's not enough light for them to really perform to see them well. So we go back to the white light. We take the filters off, and
we're showing the white light right now.
Off and on, yes, we are actually. The second telescope is a 90 millimeter H-alpha close-up again telescope that we're using to be able to see the surface granulation and speculations on the surface of the sun.
Now that, to me, looks deep red, and I think that's the hydrogen, one of the lines of hydrogen, the light of hydrogen.
It is, and along with that, for the first time, we've brought a calcium K filtered telescope, and it's about 70 millimeters. and it's showing basically a similar thing, but in a different elevation in the surface of the sun.
It looks really bluish. It's like near the ultraviolet, I understand.
Yeah, it's actually a little hard to read in television, but because of the different elevations involved, sometimes you'll see changes in the sun's nature prior to being able to see it at the chromosphere in the white light or even the H-alpha level.
Oh, good.
So it's a real special device as well. And we have a full disk H-alpha also that we're using simultaneously. They're kind of traveling together, compensating for the Earth's rotation.
And I think we are on full disk right now. And I think if you look on the opposite side of the sun that the moon is entering from, you'll see some sunspots, a sunspot group today.
We were able to capture. We were so lucky because we're at the low end of the sunspot cycle right now. But we woke up to three sunspots today.
They weren't there
pretty
yesterday.
Special. No, they weren't. At least we couldn't see them yesterday. And then we have our Corona camera, we call it. It's a wide shot camera, a telescope, if you will, that we have set to be able to witness the wonderful corona effect that happens only during an eclipse.
Now, these the white light telescopes have like filters on them. Like when I look at the partial eclipse, I have to wear this filter to protect my eyes.
Exactly.
And these cameras have the similar sort of filter on.
It's because the sun is so bright that if your eye or any object, like a television camera that we have, looks at it directly, it can be damaging and cause problems, and it's hard to process that kind of illumination.
Now, during totality, you're going to remove these.
Yes.
The telescope might jiggle a bit.
Yes, you'll see a little bit of that, and we also may, if we can provide any kind of pictures on the filtered telescopes, you may see a little bit of jiggling there too, because we'll have to be adjusting them.
Well, great. Larry Kenworthy, Magnetic Images. This is our third eclipse together.
Yes, I'm excited.
It's a beautiful day. We're going to see it.
It's gorgeous.
Thank you for bringing us your telescopes.
Thank you.
And
You're
cameras.
welcome. You're welcome.
Well, that was fabulous.
Wow. We have an array of telescopes here today.
I know, and you mentioned that we can use these special glasses to be able to look at the sun safely. They have been specially developed, and we can look at them to look at the partial total eclipse. And so during partiality, we must keep these on, but during totality, we can take them off and enjoy the full corona. So that will be very exciting. Now, let me talk to you about why it is that we are right here in C-Day right now. Why did we pick C-Day as the spot to bring to you the total solar eclipse? So the first thing we're going to do is we're going to discuss what is called the path of totality. And let's bring up the first image of that path. Here we see a map of the Earth with Africa in the centerpiece, and we see a black swath that goes across the globe, beginning at the eastern tip of Brazil, racing, that shadow of the moon races across the Atlantic at about 1,000 miles an hour, and then it enters Africa. We will see totality from countries such as Ghana, Niger, Nigeria, Libya, Egypt. Then it goes across the Mediterranean into Turkey, where we are here in C-Day, passing directly over C-Day, and then it ends in Russia and Mongolia. Now that path is made by the shadow of the moon, which is either a circle or an ellipse on the Earth, about 100 miles wide. So you see that in this animation that we're seeing now, you see a tiny black dot, and we'll run this animation again. That tiny black dot that is going through the path of totality is actually the shadow of the moon. And then you see a larger circle, which is the area where a partial solar eclipse will be seen. So this is pretty spectacular. We're very fortunate to be right here in C-Day. And so we're going to locate that wonderful town on the map. So the next animation will actually show a map of Turkey, and then from then we will be able to see C-Day. So can we have the next animation, please? So C-Day is a wonderful town, and later on we will have the mayor come in and show us some of the beautiful sights here. But as you can see, there's a map of Turkey, and C-Day happens to be on the beautiful coast of the Mediterranean. So to tell us a little bit more about the town, we're going to introduce Mayor Osman Delikulak, who is here to welcome you to his town.
Thank you very much. You're welcome.
You're most welcome.
It is nice to see you here.
It's great to see you. Please give us the welcome to the broad audiences that we have internationally.
Welcome everybody. It is so nice to see you here. I say hello to all over the world who watch us.
Oh, thank you so much. And I have been walking around the town of Side, and I've been seeing such amazing sights that I think it's worth it for us to look at some video that our crew took ahead of time, and so that the mayor could describe some of the sights and give you a tour. So let's see some of these beautiful sights.
Now you see antique Side, some beach in Side, and now you are seeing main street of Side. This part of Side, the people can buy something, and they are playing card games in the coffee house in Side, and some women making flatbread with cheese and meat. They do it homemade. You see something from our natural, healthy things for your stomach.
Looks like a nice market.
Some medicine, natural,
medicine,
natural medicine, and some fishing. Somebody fishing in antique Side harbor from Roman time, 2,000 years old. This is Apollon temple. Now, this is Apollon temple, and Turkish flag, as you see. This is something from Roman time, like Turkish flag.
That is very interesting.
And this is Colonial Street, entrance of the Side, from Roman time and Byzantine time. Some ruins from Side. Antique, this is Basilicum from Roman time. Now, antique theater, it is 15,000 people. That means Side was 75,000 people. Now you see Agora of Side, antique Side.
That was like a big market, right? Big ancient market.
Here was the center of Pamphylia area, ancient time. Side was the center of other Perge, Aspendos area.
That's a beautiful temple of Apollo.
Apollon Athena temple. We are going to restore it now.
And right now, there's many, many thousands of people around that temple watching the total solar eclipse or waiting for it. So this is very exciting. Are you happy to have so many people come to Side?
We are very happy that you are here. We thank you all. We hopefully you come some more. Then some more people come here, hopefully.
Well, I'm definitely planning to schedule a vacation with my family to Side, because I have to say I have enjoyed every minute, and it's not just the beautiful sights. I have to thank you, Mayor, for your wonderful hospitality and the lovely times that we have had with everybody here. Everyone is so friendly and welcoming, and I think that people can have a wonderful experience. I think right now we're seeing some more of the archaeological explorations that are still going on here.
Yeah.
That's very good. I have heard that in Turkey there are more Greek ruins than in all of Greece, and more Roman ruins than in all of Italy. So how about that? Is Turkey a worthwhile place to visit?
It is true. You are right. When anybody come, always welcome.
Oh, thank you. Thank you so much.
We thanks to you.
We appreciate
We thank you.
your being here. Thank you very much.
We thank you.
Everybody's cheering the mayor. Thank you. Thank you. Oh. That's been fabulous. Thank you. Wow, Paul, what a lovely welcome to the mayor.
That was great.
This is great.
Well, let's take a look. The about 25% of the sun is covered now by the moon, so let's switch to our telescopes once again.
Let's look at that.
Oh, there we go, and you can see how it's beginning to make the symbol of the Turkish flag out of the sun. The moon is just progressing across, and so I have to ask my question here. What do we see? What do you see in this image? And now we've zoomed in and we're showing 3 sunspots. The first 2 there, a dark one and a lighter one, make sort of a pair, and then one really close to the limb of the sun.
Oh, that's amazing.
That was astonishing.
We're going to get different views of the sun as well. But I have to say I'm very pleased that we are seeing sunspots, because we are right now at solar minimum. We'll explain a little bit about that, what that means.
Right. And so I have a question for you, which is What is the sun?
What is the sun? That's right. Well, let me tell you what is the sun. Well, in every total solar eclipse, the sun is the star of the show.
Yeah.
And we mean that quite literally because the sun is our nearest star. It's a huge, enormous ball of incandescent hot gas, and it brings us to Earth and other planets the energy and the light that we need here on Earth to sustain all life. Now, the sun is very huge. As we have mentioned before, 400 lunar diameters can fit in the diameter of the sun, and more than 100 Earth diameters can fit in. Now, if you were to pile in a bunch of Earths inside the sun, oh my gosh, you would fit more than 1 million Earths. So that is truly fantastic. So these images that we're seeing on the telescope right now are showing that enormous sun.
Look at those wonderful prominences.
Look at that.
It's going to be quite a show during totality when the moon blocks the sun and we can see them reaching up beyond the edge of the moon. Watch for that.
That is truly fantastic. The sun is such an amazing star, and we're so lucky to be part of the solar system. It's a star that is at the center of the solar system, and all of the planets and the Earth revolve around the central star. Now, let's talk a little bit about how hot the sun is. In the center, the sun is many millions of degrees hot. As you move out from the center of the sun towards the surface, the temperature goes down. When you reach the visible surface of the sun, called the photosphere, the temperature is about 6,000 degrees. But then you might expect that it would continue to go down, but it doesn't. It goes up into the other layers. So let's look at those three important layers of the sun in our next image. So in the upper left, we see the photosphere, or the visible surface of the sun, and we see a couple of sunspots there. On the upper right is one of the outer edges of the sun, called the chromosphere, which is part of the atmosphere of the sun. In the lower part, we see the corona. And that corona is what we're going to see during the total solar eclipse. And that will be fabulous.
Right.
So the sunspots are very important to us in terms of our understanding of the sun, because they have a magnetic nature. They are actually the footprints of the magnetic activity on the surface of the sun. So let's look a little bit more about let's talk about sunspots. Look at a movie that we have of the rotating sun. So that's the next image. We see a rotating sun. It rotates on an average of 29 days. That's the period of rotation, and we see many beautiful sunspots there. Okay, as I have mentioned, the sunspots are actually a representation of the magnetic activity of the sun. And if we look at the next movie, we can see more details of what a sunspot is. As you can tell, there is a dark area in the center, and a little bit, the orange part around it is a little bit less dark area. It turns out that the sunspots are dark because they are cooler than the surrounding surface of the sun.
Cooler, but not cool.
Cooler but not cool, indeed. There's only about 1,000 degrees cooler than the photosphere, which is about 6,000 degrees. So if you took a sunspot and put it up against the bright sky here on Earth, it would shine almost as bright as the sun itself.
And here we are looking at the sunspots that are up on the sun right now.
That is fantastic, you know, and one thing about sunspots is that they predict what we call the solar cycle.
Right.
They actually mark the solar cycle, I should say. And perhaps we should look at a next image that shows several images of the sun.
Oh, actually, they interrupted one. This is a hydrogen alpha picture,
and
the sunspots are showing up as a brighter area in the hydrogen alpha with a central dark core. I guess that's a plage around the sunspot?
Yes, that's a plage around the sunspot, the brighter area, and you can see a lot of detail around it. Now, in this particular light, the sunspot shows with extreme detail. It's a beautiful filter, I have to say. We're very lucky to have it here.
This is the hydrogen alpha.
Yes, from our telescope operators. And that red light that you see is just the red light that's picked up by that special filter.
Right. But we're actually now going to show...
Yeah, why don't we show a next image that actually shows the sun.
Yes.
Sort of a composite of many images of the sun taken over a period of several years. So in the upper right, you see a dark image of the sun in which there are very few sunspots, so the sun is less active. And then on the lower left, you see a much brighter sun, which basically is the result of more increased activity and more magnetism.
The sunspot cycle.
The sunspot cycle, it takes 11 years for the cycle to occur, and it turns out that at this point we are at solar minimum. So the fact that we see so few sunspots on the sun, and maybe we should have one more telescopic view in white light of the sun so that we can actually get a better detail of the sunspots that we're seeing right now.
Right.
So we're looking at the white light filter image of the sun,
right.
and you can see 3 dark spots sort of in the lower around 7 o'clock.
Yep.
And those dark spots are the actual sunspots that we see today. Now, there's very few of them because we happen to be at solar minimum.
Right. Well, very good.
Now, the neat thing about sunspots is that you don't need such sophisticated equipment like those telescopes to be able to view them. We can actually use very simple equipment such as cardboard telescopes.
Right.
And we have invited some students to show us that.
So let me take you over there.
Okay, let's go.
Come with me. Well, I'm here with Troy Klein. Welcome,
Paul.
Troy.
Hello, Paul. How are you?
Doing well. You notice the light is fading?
It is, and I actually think I'm feeling a little bit of a temperature change right now.
I think so.
It might be in my mind, but...
So what do you have to show us here?
Paul, we have, right behind me, we have a solar scope.
Yeah.
And a solar scope is normally used to view sunspots like you were just talking about.
Right.
Well, just to my right, we have some students from C-Day, high school students
Yay!
from here in town. And they have set up our solar scope for us. And instead of it looking at just sunspots, it's now doubling into an eclipse viewer.
Oh, wow. Well, that's amazing. You can see the eclipse happening, and just opposite the sun, there are those 2 tiny dots.
Maybe I can move over here and I'll look too.
Right.
Oh, that is absolutely beautiful. And you can actually see the dots, just like you said.
Yeah.
And I didn't see those sunspots yesterday. And in just a few moments, in just a little while, our students behind me are doing several activities. And in those activities, you'll be able to see about 7 different ways to view the eclipse safely.
Yes.
And that'll be a wonderful experience.
Well, great. We'll return to you then. And
Check
your group
back
of
with
students.
us. We'll be
That's
working.
Great. Okay. Thank you, Troy.
Okay.
Well, hi again. We're back, and we have to continue our question, which is, what is the sun?
Well, we've talked about the sun from the point of view of its quiet nature. We talked about the fact that we are in solar minimum right now. Also, our relationship with the sun is quite reliable. We expect the sun to rise every morning and set every afternoon. And here it is, right above us.
I now notice that it's getting darker, and it's just strange in the middle of a beautiful, bright, clear day.
It's amazing how the shadows are different. You know, I put my hand out, and the shadows are just not as sharp as you would expect for this time of day. It's truly amazing. It's a beautiful spectacle. Now, the other thing that we want to talk about the sun is to show you some of the features that you might possibly see during the total solar eclipse. Yeah. Now, during the eclipse, you see the outer edges of the atmosphere of the sun, the chromosphere and the corona.
And that chromosphere will be nice and deep red, or reddish.
That will be wonderful. That's why it's called the chromosphere, because basically it's the colored part of the atmosphere of the sun. And so we'll be able to see that.
Great.
And some of the wonderful features that we might see there is actually some of the material from the sun streaming out from the surface, because the sun doesn't only give us energy, light, and heat, but it turns out that it also gives out a constant stream of charged particles called the solar wind. You know, one amazing thing that always stuns me is to think about the fact that the Earth and the other planets in the solar system are actually embedded in the atmosphere of the sun.
Yeah.
It's really a cool thing. So let's look at the next image where we can see a prominence. Now, here's an extra. Isn't that a fabulous image? Because, of course, we're seeing this image of the sun taken by a satellite from NASA. A satellite that has taken this image from space. Now, the prominence is the actual loop that you see emerging from the surface of the sun on the upper right at about 2 o'clock. Now, a prominence is a cooler material from the sun that is hovering over the edge, held in place by the magnetic forces generated by the sun.
Here we have 2 live prominences.
Look at that. We see 2 beautiful prominences that are on the sun right now.
I think I can see them changing from view to view as we go through this eclipse.
That is true. We can see some change in the structure, and it is just such a beautiful, phenomenal luck that we have that actually the moon hasn't covered this part of the sun that's showing some of the prominences. So
yes.
We're very lucky today.
It's coming.
It's coming, definitely. Now, the next thing that we're going to see is actually an image of a flare, which is another representation of the very active sun. Now, this is an image taken by one of the NASA satellites called TRACE. You can see sunspots in there in X-ray. You can see the magnetic loops and that amazing, almost like a vibration caused by a gigantic explosion on the sun that we call a flare.
You know, this reminds me of when I was a kid and I'd sprinkle iron filings on a magnet. So
right.
It really is a magnetic sun.
It is amazing how all these charged particles actually follow these invisible lines of force caused by the magnetism of the sun. And if we watch closely, during totality, we might be lucky and we might see an actual flare. So
yes.
That will be an exciting
wow.
thing to see, something that we don't normally get to appreciate. So that'll be fun.
I think we have a still even of a
I think
CME.
we have a still. We have one more thing that I want to explain to you, and I will need a little bit of your attention because this image sometimes is difficult to interpret. Basically, we have the ability to use special detectors in space from satellites that create artificial eclipses. What we see here is an artificial eclipse of the sun from space. The dark circle in the middle is actually a coronagraph or a detector that creates this artificial eclipse, and the inner thin white circle is the actual surface of the sun, the size of the physical sun. Now, why it is that we have darkened the sun with this artificial plate, the coronagraph, creating an artificial eclipse, is because the sun ejects thousands of these so-called coronal mass ejections during the period of solar maximum. And sometimes those particles will reach the Earth and affect our technology and other aspects of our space exploration, including the safety of astronauts.
Well, I think we actually have a guest now, Dr. Janet Lumen, who is an expert on this, and I think I'd like to bring her in.
I think maybe we'll bring her in, but I think first we have some crowd reactions because everybody's getting so excited about what's going on. So let's see.
Nahide Craig up there in the crowd.
Let's see.
We're 5 minutes over. I was cutting her.
Sorry, I didn't.
Oh, you didn't hear? Okay. Oh, we don't have Nahide, so let's go bring in Dr.
Let's
Janet
bring
Lumen.
Janet Lumen.
Hey, Janet Lumen, welcome.
How are you, Paul?
I'm great. How's it feel?
Oh, I'm just so excited.
Somebody
feel it getting
needs to go
cooler,
tell Robin that I cannot
and
hear her over the
crowd is
noise.
just getting all cranked up.
And tell her that I have my volume up.
Now, we were hearing about these coronal mass ejections and what this means for life on Earth, the sun. So what can you tell us about that? What do you have to show us?
Well, you know, the coronal mass ejections are something that is a characteristic of an active sun. And right now you have to realize that we're going to be seeing the sun in its quietest state.
Yeah.
And in fact, some of the pictures you were looking at with the sunspots showed you just how few there are and how small they are. But eventually there's going to be more and more sunspots, and the solar magnetic field gets more complicated, and then
Can you ask
erupts.
Robin if we have the phone
And
calls?
sometimes these eruptions can, in fact, encounter the Earth, and they produce the equivalent of space weather storms. We have a whole other meteorology of space weather.
Well, I think you have some images to show us.
Absolutely. In fact, you have already seen the SOHO images of coronal mass ejections, and now we're going to see some images of the coronal mass ejection encountering the Earth.
Oh, let's take a look at the first image there, the movie, I believe, of the coronal mass ejection.
The first image is the still.
Yes.
And
actually, I think the first one was the CME movie.
The CME movie.
Right.
There's the SOHO movie.
Yes.
And what you see here is an active sun. So you can't plan on seeing this when the sun is obscured today. This was taken by the SOHO spacecraft, which is a cooperation between the European Space Agency and NASA.
Wow, that's an active sun.
We get to watch these all the time with the spacecraft. But today, with our naked eye, we're going to be able to see some of this outer atmosphere of the sun. But it's not going to be quite so dynamic when we see it. It's going to be a much more quiescent sun.
And this is also taken over several days. It's a time lapse.
This is taken over several days. It's a time lapse. We're going to have 4 minutes of totality in which to see the corona. And this is really a rare opportunity.
Yes.
How often do you get to see the outer atmosphere of the sun with your naked eye on a beautiful day in C-Day?
Right. Well, let's take a look at our space weather still.
The space weather still.
We have a still image of the.
Shows coronal mass ejection approaching the Earth.
Yeah.
And there it is. It's sweeping up the ambient solar wind, which you learned about from Isabel earlier. And in the course of doing that, it plows into the solar wind, making a big shock wave that travels toward the Earth at huge speeds compared to those you're normally familiar with. Some coronal mass ejections approach Earth at 1,000 kilometers per second when a speeding car travels at 100 kilometers per hour.
Wow.
So it's quite a difference. But
Yes.
it produces some disturbances of the Earth's space, which you see on the right of this picture.
Right.
The Earth has a magnetic field, and because of that, it's protected normally from a lot of these particles and magnetic fields coming from the sun.
I think we have a movie of what happens when one of these CMEs smashes into our Earth's magnetic field.
Here you have an animation showing a CME, a coronal mass ejection, a piece of the sun's atmosphere carrying some complicated solar magnetic field, plowing through interplanetary space, encountering the Earth's magnetic field and disturbing it greatly. And this produces many effects that can affect us in our everyday lives.
It looks like it's making something around the poles here.
You can see an aurora,
Yeah.
which is one effect of the disturbed magnetic field of the Earth. But there are other things too. There are ground currents that occur which can cause power blackouts. There are disturbances in communications. There are satellite problems, and I think that you will begin to hear about those as we approach the solar maximum in a few years.
Great. So it has real impact on us on Earth. Well, what can we do to predict these and to tell when they're going to hit us?
Well, we are sending out a new mission for NASA called the STEREO mission. STEREO stands for the Solar Terrestrial Observatory. It's a 2-spacecraft mission, and launch is due to occur in July of this year. The launch window opens in July. One spacecraft will travel ahead of Earth in its orbit, and the other one will travel behind the Earth in its orbit. They will get up there and separate while they're still close to the Earth, and then use a gravitational assist by the moon to get into these heliocentric orbits. Then they will function as two eyes.
Two eyes, stereo view.
Stereo view, and we will see stereoscopically these coronal mass ejections, be able to better understand their structure, their speeds, and how better to predict them and their effects on the Earth.
Wow.
So it's going to be fantastic.
We'll look forward to learning more about the sun.
We are so excited.
Well, enjoy this eclipse. I understand it's your first.
This is my first total eclipse.
And we'll bring you back afterwards and you can tell us some more.
Absolutely.
Thank you, Dr. Janet Luhmann.
Thank
Yay.
you, Paul.
Okay, let's take a look at the sun. Oh, it's just spectacular. Look at those prominences, and the moon is sweeping down towards them. They're in the perfect position to last out this eclipse.
This is amazing, Paul. We're 20 minutes from totality.
Yes.
And it's amazing to think that on that path of totality, in Africa, we have some colleagues in Ghana who actually have already seen totality. And we are so fortunate to be able to hear from them. So first, why don't we place Ghana on the map, and we're going to get the next still image that is going to show exactly the position of our colleagues. And there we are. The red star is showing where our colleague, Dr. Kennedy Reed, is stationed in Ghana, and they have already seen totality. So we're going to ask them what they saw. And next, first, please, let's have a picture of Dr. Reed so that people can visualize who it is that they're hearing from. Dr. Reed, can you hear me? Dr. Kennedy Reed from Ghana, can you hear me?
Okay, I'm standing here with Professor Mead Quainer. Just before totality, there was clouds, but at the time of totality, we had very clear viewing. We were able to see the corona. There was a lot of shouting, and it was beautiful.
That's exciting.
That is wonderful. I am so glad that they were able to see.
It was very exciting.
Oh, great. Well, Dr. Reed, we thank you so much for giving us a preview of our upcoming attraction, which is, of course, the total solar eclipse. We're getting very excited, but we really need to go to continue with our program because the sun is about to be completely covered by the moon.
Right. We have a schedule from the sun.
Definitely. And here we have a telescopic view in H alpha, and you can see that we have just a thin sliver of the sun that is left.
Well,
so that's a fantastic thing.
To Troy Klein, who has the students ready to show us how to look at the eclipse by looking down. Hi, Troy.
Hello,
again.
Paul. How are you?
Good, good.
Our students are having an absolute amazing time right now. And we have 7 activities that I want to show you. We have an entire classroom, an English class from Turkey here in C-Day. And hello, everybody.
Hello. Hello.
And our first student is going to show us how to do the simplest of observations.
Oh, wow, look at that.
Look at the images. She holds her fingers up just in a crisscross fashion. We can all do that.
Yeah.
And it's truly amazing to watch that. It's right through your fingers and you see the eclipse. Now we have a second activity, and our student just over to my right, she has a pinhole projector. And if you look at simply a paper plate with a hole punched in it, look at that.
Yeah.
And she's going to hold it up and project it down onto that gray card again, and we have another eclipse image.
A crescent sun.
A crescent.
How appropriate for Turkey.
How appropriate. All we need is a little star hole right there on the side. Now our third student has one of the simplest ways to view. Look through the branches of a tree. You see just hundreds of eclipse images dancing right across the surface. Look at that. And if she moves it in and out, if you can go closer, look at that. I just couldn't believe how easily that works. So everywhere in the path of totality, people can look under any tree, hold up any branch, and they will see just the same thing we're looking at. Now our fifth student, if she comes over a little bit, she's holding up a simple colander, and if she twists it back and forth like this, can you twist that for me? Can you rotate it?
No, the other way.
Can you kind of go like this for us?
Oh, yeah.
If you notice, the image, even though we're rotating, the image of the eclipse is still exactly the same. It's the same shot.
Yeah.
Now we have another student, and over here to my right in front of me, he is going to hold a little image with a mirror. It has a triangular spot in a piece of paper cut out, laid over the mirror, and then he's reflecting it over to just a white card. Now the reason we're doing all of these different activities, and I can see the dot right there, the reason we're doing this, these are all very safe ways to view an eclipse.
Right.
Wow, I can feel the temperature going down
rapidly.
rapidly.
In fact, let's go right to the temperature.
Okay. Right over to the left, we have students with Carolyn Ing. She's helping them. And if you look, they are monitoring the temperature range right now. And Carolyn, can you tell me how far has the temperature dropped so far?
Yes.
It went from 70 down to 67 already, and it's still dropping. It's dropping rapidly. So there you have it. When you come back in a moment, we'll give you the full report.
Thank you, Troy.
Thank you, Paul.
Let's go back over here to Isabel.
Oh, fantastic. This is so great. I am feeling a chilly air, Paul.
Yes.
I don't know how it is that you're reacting, but it's getting darker, and it's definitely chillier here.
Okay, so in fact, we saw what we can see looking down.
Right.
If we look up with our glasses, and you must still continue to look at the sun, even when it's just a sliver with your glasses, you must look at the sun looking up with your glasses. Now, the thing is, as we get closer to totality, just before totality, the edge of the moon, this wrinkled edge of the moon, will let bits of the sun shine through.
And what are those things called?
And so the little dots of light around the edge of the sun are called Bailey's beads, and they're really fun to look for. And if there's an extra large one, we'll see what's called a diamond ring.
That's fantastic. Now, can we see a picture of the moon that shows actually those craters through which the light of the sun will emerge so that we can see some of these effects? I think we have a still image of the moon. There it is.
Yes.
Oh, that's fantastic. That shows those craters, and then the light of the sun will actually go right through them, and we can see those wonderful, wonderful effects.
That's right.
Now, I think we might have a call from Libya, because they have also experienced totality, and they're a little bit earlier on the path. So
Okay.
I'm waiting to see if we have that call.
We don't have that call yet. I'll also say that during totality, it's going to get so dark, the sky will get dark, and the bright stars and planets, we might be able to look up and see Mars and Mercury with our eyes here in the studio. So.
Do we have an image of what the dark sky will look like during
that's right.
totality?
We may have that image to show.
I think so. I think we had planned for that. So
Okay.
let's
No,
look
we
at
don't have
this
that.
still. Oh,
So-
okay.
Well, one thing we can do, since while we're waiting for our call from Libya, is to go to Nahide Craig up in the audience. Do we have Nahide up there? Oh, there she is. Hey, Nahide.
Hi, thank you, Paul. We have here a couple of high school students. Actually, we have 600 students, but I have two girls that I like to talk with them. So,
Ayşe Güneş, Elif Aydın.
well, one of the girls' last name is actually Sun. Well, that was totally coincidental. Bundan önce Güneş'i görmüş müydün?
Görmedim. Ben tutulmayı 99 yılında görmüştüm.
Well, one of the girls has seen the eclipse, the north of Amasya in 1999, but the other has never been seen one. Nasıl hissediyorsunuz şimdi kendinizi?
Şu an üşüyor hissediyorum. Evet, burada bu zamanlarda görünmeyen bir soğuk var.
Now, she said she's getting chilly. It is an unusually cool feeling because we had a real warm morning this morning. So it's noticeable, and even the darkness, I believe, is noticeable. Karanlık olarak da görüyor musunuz?
Evet, karanlık. Evet, bugün havanın iyi olmasına göre çok karanlık.
Siz niçin bu konularda ilgileniyorsunuz?
Ben astronom olmak istiyorum yine.
So they are here not just because the school wanted them here, but they also are interested to be astronomers in the future. So we are going to be back to Paul, and we will continue watching. It's getting very, very close. Thank you, Paul.
Okay.
Okay.
Evet, çok şükür biz gidebilir miyiz artık?
What an amazing experience. I am just getting chills, literally and figuratively, about the excitement of this amazing spectacle.
Well, I think it's time that we switch to all telescopes on the sun
All the time.
all the time. So let's go. It's getting close to totality. So there it is. Look at that amazing thin arch that's left.
So we're going to get some reactions from some of our participants here, and I think maybe we should ask some of the students how it is that they're feeling and if they see any difference in their experiments.
How are you feeling? Very excited.
Very excited.
Yes.
Do you feel that it's colder? Yes, very much so. Very much so, definitely.
Look at the branch one more time.
Let's look at the branch one more time and see if we see. Oh
Little
my goodness!
tiny
There's
arcs. Isn't that amazing?
very tiny crescents.
Just about safe enough for us to actually look at the eclipse in just a moment.
Yeah. We actually have to wait a little bit longer. Yes. We can look by eye.
Yes, the audience is still using their glasses. They're all very excited, looking up. There's a buzz in this beautiful antique theater, a 2,000-year-old Roman theater here in the beautiful city of Side.
Well, as we look at our solar image again, we can see one of those sunspots about to be squashed between the edge of the sun and the edge of the moon. Just that one little dot on the edge there. Be interesting to look at that location during totality to see if there's anything we can see outside the limb of the sun. Oh, and here we are in calcium, the calcium K line. It looks so blue to the telescope, and it's just and over where the sunspot is, there's kind of a brightening here.
Definitely,
instead of being the
brightening.
sunspot dark, I guess above the sunspot it might be hotter and brighter.
Absolutely.
In this calcium K line.
Ultraviolet light.
Right.
And that's why it looks blue. This is a picture of the sun going through a blue filter, and now we're back to the white
it's the
light,
close-up,
seeing that
the white light
beautiful
close-up.
sunspot. Look at that.
Yes, indeed. And in fact, I believe I can actually watch the moon move in this enlarged view. Here it comes.
Oh.
Got a few wispy clouds up there, surfing in on the edge of the shadow.
Yes, but I don't think they're going to interfere with totality. We have a beautiful day today in C-Day. Oh, the crowd is just buzzing.
Yes, I got it. No calls from Libya.
Wow, this is incredible.
It's great to go through our whole array of telescopes here and see images of this eclipse in different wavelengths and different colors. And here's a dark red, the hydrogen alpha again.
Yes.
And we can see that sunspot. in fact, right near the edge, near the sunspot, there's considerable some brightening.
Yes, I can definitely see that difference. So
about
when
7
we
o'clock.
enter totality, watch out for the Bailey's beads,
Yes.
those little brightenings around the craters of the moon.
Yeah.
Watch out for the diamond ring effect, in which you
Yes.
see, really, you can't miss it. It looks exactly like a diamond ring effect. And also look to see if you see any flares or any coronal mass ejections.
Okay, the mayor's going to be coming. We hear the mayor's coming back. We'll.
Oh, the mayor's coming back soon, and might get some reactions from him. I'm sure he's very excited. Oh, there he is. Oh, this is wonderful. We're going to have such a good time during totality. Oh, I'm sure people are getting very excited. Also, all over the museums and the other venues where this eclipse is being shown. Mayor Delikolak, how are you? How are you feeling?
I'm feeling very good, excellent.
Are you excited?
I'm very excited. It's very, very good, very excited.
What do you feel physically? Do you feel any change in the temperature or the darkness or brightness level here? Are you noticing any changes in the theater?
It's going a little darker, and it's getting cool. It's getting cool. I feel a little cold.
Yes, really
Yes.
cold wind.
Darker and cool. It's a strange feeling. It's very different feeling. I have never met a feeling like this till now. I hope that I never forget it.
Yes, me too. I've never had a feeling like this either. Well, thank you so much, Mayor. We'll be talking to you later.
Thank you.
Enjoy the eclipse.
Great. So we're down to just a little under 3 minutes until totality. There's just the tiniest sliver. There's another phenomena we can't show you because it's impossible to photograph just about, and they're called shadow bands. And so as we look at the floor of the theater, we might see some dark waves, like faint shadows rippling across the surface. And as the sun is reduced to a tiny slit, it allows us to see these waves in the atmosphere. It's like being on the bottom of a swimming pool, but the swimming pool is the atmosphere.
Wonderful.
So I have a white sheet spread out here to let people see them. Although it takes a human eye to see it. And,
you cannot photograph it.
My mentor from MIT, Phil Morrison and Phyllis Morrison, taught me about laying out a white sheet to allow people to see the shadow bands.
That's fantastic. Paul, I've never seen a total solar eclipse, so
you're about to.
I am just getting so excited.
Yeah, that's really interesting. You can sort of see the thin sliver here, especially where the moon is the point of the sun here. You can just watch it going away.
Yes, it's almost like that little point is being reduced by the second.
We still have to use glasses. It's definitely darkening very quickly.
It is darkening very quickly. We must still use our safety glasses to look up at the sun.
You still must use your glasses.
But definitely we are...
Who do we have on the line?
Javilla.
Oh, Javilla!
No,
here he coming. I think we're coming to totality. Yeah, the crowd is going wild as the last little bit. Okay. Okay, so the camera has had its filter off. We're looking at the very edge. Still use your glasses. The crowd is just going wild here. Just wild. Oh, wow, there's going to be a prominence right above the edge of the sun. Perfectly centered in the eclipse line. It's quite beautiful. Oh, it's dark. It's getting dark quickly. No shadow bands this time. Yay, Isabel! Wow. Here it comes. Here it comes. We've got the camera. Oh, we got some Bailey's beads. One last little dot. And now. Oh, wow. It's incredible. There's these streamers coming out in the corona. It's the most amazing corona I've ever seen in all my solar eclipses. Here we are at a period of quiet sun, the minimum, and yet the corona is fantastic. There it is. We have it in our white light view now. And you can see the complexity of these streamers. In fact, some of them are called helmet streamers. They look like a Greek helmet. Yeah, the crowd really gets, yeah, see, it does get you. Oh, stunning. And now, as our eyes are adapting to the darkness, we can see the streamers reaching farther and farther from the sun. Just a tremendous distance, like this big white spider in the sky. And there are details in our photograph. You can see the magnetic nature of the corona, the lines. Some close-up of the edge of the sun and the corona.
Fantastic. So nice, yeah. Very exciting, really.
Teşekkür ederim.
Ben teşekkür ederim.
The corona is really bright around the edge of the sun. It's quite bright close, and there's lots of structure to it. Oh, where are the planets? I don't see the planets. Our students are enjoying it. Little screen there. Yeah, the light is glowing around the horizon, scattering on the clouds and making it just a little too bright to see the planets.
The prediction.
It's just like the prediction.
It's incredible. You're going to have to talk about that.
Wow. We're about midway through the eclipse here. It's amazing to be able to see the overall magnetic field of the sun sketched out in the lines of the corona. Yes! It's fantastic.
Fantastic.
Total solar eclipse, I bring you, Robin. And we're bringing this live to the Exploratorium in San Francisco. Hi, Linda and Ron Hipschman. Linda Shore and Ron Hipschman is hosting there our wonderful eclipse program. Oh, the birds are coming in to land in the theater. So this solar eclipse is brought to you by the sun, the moon, the earth, NASA, and the Exploratorium. I see at the lower part of the sun right now a bright red dot. It's like the chromosphere, one part of the chromosphere, maybe a naked eye prominence. In about 5 o'clock here in our naked eye view. That, I've never seen something like that in the middle of an eclipse. Oh, wow. Yeah, that's the most amazing red as the chromosphere begins to come out, being unveiled. That's really unique, that red. Here it comes again. Here comes the sun. Let's go to the whole sun view. Diamond ring, a fantastic diamond ring. There it is. Oh, wow. Time to go back to glasses.
Woo! Glasses back?
Yeah. Wow. Yeah. So there we are back. The light has returned. Let's switch to some of the other telescopes again, maybe the Hydrogen Alpha. How did it go with the still cameras? Oh yeah, we've got a little saturation here on our filters. Someone needs to cover up that telescope. and switch. Wow. Well, Isabel, once again the sun returns. We're saved by the laws of celestial mechanics.
This is fabulous, Paul.
I noticed you had a tear in your eye in the middle.
One or two, I have to admit.
Yeah,
but look how dark we are still.
Yes.
It's amazing how dark we still are and how cool it has gotten to the point that I'm very glad I have this coat on.
Oh, it's great to see the sun coming back, and I think we're going to go over and check a few things over here with Troy and the kids.
Yeah, see how their temperature measurements
Yeah,
went.
let's come over here. So,
Carolyn, why don't we take a look at our temperature measurements right now with Paul and Isabel?
yeah.
And what have you recorded so far? I'll move over to that side so I can hear
What we
them.
do?
No.
Something to do?
59. 59. So we started, it looks like at 70, and then your graph a little above 70 degrees Celsius, and then it went all the way down to, it looks like 64. So we had quite a nice drop there. It's amazing to see that.
Wow. What did you think? I heard some screams. Incredible. Like something you'll remember your whole life. That's to
A
think
unique
this.
experience.
To think the sun is like that all the time, but you can't see it because you need the moon to block it. So remember that whenever at sunset, when you can look at the sun, it's got those coronal streamers coming out of it. Always remember.
Thank you, Paul.
Well, thank you all. Yay.
Thank you.
Yay. I'm back on my spot.
What a fantastic experience, Paul.
That was amazing. And okay, actually, we understand we have a replay tape. We can take you just like in a sports event.
Oh,
we
yes,
can do
instant
the
replay?
Instant replay of the eclipse. So let's
That's
go
right.
look at it again.
Let's go look at it again, and I'm going to call on Janet Lumen to come
Yes.
back and
Yes.
tell us a little bit about what she saw.
Yeah, please do. Come on back, Janet. Oh, here we go again.
The replay.
This is the last 2 minutes of the eclipse, Janet. What'd you think?
Wow, spectacular. I've just never seen anything like it.
Now, you told me you studied the corona your whole life.
Yes, I have. And this is the first time I've ever seen it in person up close like that. It's just highly recommended to everyone,
Especially a coronal researcher.
especially a coronal researcher. But you know, scientists are making predictions of eclipses now.
Yes.
And you can go on the web and Google or Yahoo search on eclipse predictions, and they've done remarkably well. They use maps of the solar magnetic field and a model of the corona.
Yeah.
And it looks pretty good. So we're getting there in terms of understanding the corona, I think.
Well, in fact, I went online today. You told me to go online, and I saw the NASA scientist prediction, and they predicted 4 bright streamers. And in fact, I saw the 4, but there were a few more they didn't get.
Yeah, I'm sure there are. And of course, this is a very quiet time of the solar cycle.
Right.
During active times, the corona is very much more complicated, and I expect
Can
they
you
will do a
hold
lot
this?
worse. It's also very
And you're gonna
dynamic.
have to-
Right.
I guess
But
I'll
you know,
come
I
back
think
and
those spots
get it
that
from you.
came up earlier
Yes.
are going to be the first spots of the new active cycle.
Oh.
And it's predicted to be an even larger cycle than the last in terms of the level of activity. So
Well, it's really important that we understand the sun enough to make those predictions so we can be prepared for our power networks and our communications networks and satellites.
and just for the wonder of it and the beauty of nature.
You can't miss that, and that's
Fantastic.
what we had today.
That's right. We're the family of the sun, all of us.
Well, great. Thank you,
Thank
Dr. Janet
you,
Lumen.
and thanks for the
Yay.
wonderful experience.
Oh, sure. Okay, so we're
is
back in the theater,
incredible.
and it's now brightening up quite quickly. It was
Yes.
amazing how dark it got there for a while. Although it wasn't as dark as I've seen on previous eclipses. There was just a little bit of high haze that caught the sunlight shining in from the edge. This spot, the shadow, is only like 100 miles in diameter.
Right.
And so if you look at the sky, it's like a 360-degree sunset. And the light leaking in from the edges illuminated the clouds and made it so I couldn't see the stars or the planets this time.
Right, this time I tried to look as well, and I could not see. Oops, we
Yep.
have some planes flying
Oh,
by.
yeah.
So I tried to see the stars, and I could not see them either. It was quite lighter than I would have expected.
Yes.
But what a beautiful corona, and I was so amazed to see that the predictions by the
Yes.
space weather scientists were actually so close to what we saw.
And that chromosphere at the end,
Oh.
the incredible red point that came out first as the moon was unveiling the sun. In fact, here as we look again, look at all the prominences on the edge of the sun
We
revealed in
had
our live
a
image.
magnificent natural show by our star of the sun, no doubt about it.
Wow.
Now, is it, it's just so amazing to see how dark it got here in the theater.
In fact, Nahide Craig, up in the audience there, is going to be giving us some crowd reactions and see what they thought.
That's wonderful.
Yeah. So, back to Paul. Everybody's moving here already, but here is a gentleman I want to ask about his opinion.
99'da depremde İstanbul'daydım o sırada. İşte ondan sonra 17 Ağustos'ta bir hafta sonra falan aşağı yukarı bir deprem yaşadık. Aynı şeyi şimdi merak ediyoruz.
Evet.
Aynı şeyi de merak ediyorum. Acaba olacak mı olmayacak mı diye. Onun incelemesindeyiz şu anda.
Hava karardığı zaman nasıl hissettiniz kendinizi?
Bir şey hissetmedim. Normal yani bir doğa olaraktan ama tabii onun bir yaratmış olduğu çekim gücü olduğuna inanıyorum ben.
He was saying that during the total eclipse, he realized the gravitation of the moon. He said he almost felt what it was like. And he also said that during the 1999 eclipse, he had seen it in Istanbul and partially. And then following the earthquake, he was worried. So he had this very similar question like everybody else, is there going to be another earthquake?
İnsanlarda da büyük bir değişim olduğunu şey yapıyorum. Çünkü ben bir arkadaşımın eşinin o günkü haleti, ruhiyesi çok farklıydı. Yani hiç ummadığım bir şekilde. Demek ki 17 Ağustos'ta yalnız depremden sonraki depremin yaratmış olduğu bir çekimden dolayı herhalde çok farklı bir ruh halindeydi o gün. Yani insanların depremden ve bu tip olaylardan etkilendiğini düşünüyorum ben.
He was saying that it's impossible not to be affected by these natural events. And again, he's connecting to the earthquake and how he felt. But he said that it was so beautiful, unusual. It really got cool. And he was actually touched by it. So, teşekkür ederim.
Thank you.
Yeah. Back to you, Paul. Thank you.
Thank you, Nahide. And now we'll come back down. I understand we have a replay of what it was like here in the theater, the antique theater, during the eclipse to show you how the crowd reacted in the darkness.
Let's see if we can look at that.
Let's bring up our camera view. Here it was.
There it is.
What an amazing place this is to be in an antique theater in Side, Turkey. And you can see the darkness, the white sheet down there on the ground that we used to look for the shadow bands that didn't come this time.
That's right, because because it wasn't quite so dark.
Yeah, or not so dark, and not a little bit of cloudiness maybe.
Right.
And the crowd went wild.
Yes.
They were screaming and yelling.
Didn't you think they were excited, Mayor? They were very excited.
It is very, very excited. Unbelievable, unforgettable.
Unforgettable.
Oh, what a lovely sight. And this venue, the Antique Theater, is actually perhaps the best site here in Side.
The most amazing place I've ever been to see a solar eclipse. My 7th solar eclipse.
Wow, good for you. And the next one is going to be in 2008, and it's going to go over the North Pole, I believe.
Northern Canada.
Yeah, Northern Canada.
Greenland.
Yeah, and if we're still excited about eclipses, which I'm sure we will be in the year 2017. In August, there will be a total solar eclipse over the United States.
Going from Washington State all the way down across the entire country to North Carolina. So be there.
Yes.
Well, here we are back.
Here we are back. Back in the sunlight.
Yay.
Oh, the crowd is just going crazy again. Well, I have to say that this has been such a magnificent event, and it has been really facilitated and enabled by the town of Side, and none other than the mayor, Mayor Delikolak. So I would like to thank the mayor and present him with a plaque on behalf of the Exploratorium and NASA and the entire crew. We want to thank you, Mayor, for your support and your hospitality. Thank you so much. And also we would like to present you with a NASA cap so that you can be an official space scientist.
Thank you. Thank you very much that you are here.
Thank you.
We thanks to you. I say hello to everybody who watch us.
Thanks, everyone. And I think we have many more people to thank.
Yes.
And Paul's going to do that. Thank you so much, Mayor.
Thank you.
Thank you.
Thank you very much.
Thank you.
So I'd like to start out by thanking our telescope crew, Larry Kenworthy from Magnetic Images, Aaron Rosen, his engineer, Coronado Instruments, Bill Dean, Eric Blackhurst from OPT. They made this possible. Thank also the Chan Garden Hotel who put us up. NASA, the Sun Earth Connection Education Forum. Yay! in the Exploratorium, the McBean Family Foundation, the Jim Clark Endowment for Internet Education, and the Moore Foundation helped to fund this program. I'd like to thank in particular the crew from Second Life, Amy Weber, St. Paul Sub Clio, and the whole crew there that made this image playback possible in Second Life. And in particular, I'd like to thank the entire staff of the Exploratorium in San Francisco who brought you this event. And Isabel, that was wonderful. Thanks for being the co-host. And
thank you for sharing my first total solar eclipse with me, Paul. And now let's go to the telescopes and look some more.
Yay!
Oh, is that right?
Okay. They're going to just go to telescopes for the next 2 minutes.
Niye anlattın? Tamam da burası bak sonra burası Büyük İskender. Büyük İskender en son Alaaddin tamam. Çocuklar yürüyün gelin. Hocam 5 dakika için. NASA'daki arkadaş bize yardım edecek. Ben size tercümesini de yaparım. O da Hazal ablacığım. Hadi görecekler, bakacaklar. Tamam, tercüme edeceklermiş.
Şu an çek alamıyorum. Sadece çocuklar Alanya'dan geldikleri için.
Ne oluyor? Onların her şeyini geliyor. Şimdi fotoğraf çekiyorlar. Gidelim ondan sonra 5 dakika gelecek. Konuşması kameralar. Şeyleri dökmüş konuşacağız şimdi. Şöyle konuşacağız. Kim o? O bayanla buradaki parmaklar görünüyor. Bakıyor muyuz zaten? Aynı şey. Yani informasyonunuz varsa onlar da var.
Abi aydınlandı.
Öğrencilerle burada program yapmış. Ne kadar güzel. CNN'de mutlaka göstermiştir. CNN göstermiştir çünkü canlı yayın atıyor.
Yok burada. Burada. Nereden iniyoruz?
Hadi bakalım şuradan gidiyor.
Hocam bir dakika e-mail adresi almadan gitmez. Onu bu taraf öne doğru ittir.
Hadi gel. Oğlum biraz kafana
Nerede?
Orada gel.
Ya buradan iniş de berbat yani. Aman yarabbim. Yardım et bana. İnşallah. Kopacak kızım.
Fatma sana yardım. Ben kendim de yapıyorum.
Burada neler oldu?
Hadi ya.